Hello and welcome to a low class day. We shall be looking at Surds. So I hope this is not the first time you're coming across this term. And if it's the first time, not to worry, I got you. So we are basically going to, in today's class, define and understand what a Surd is. All right. So I'm going to start from familiar ground. I want to start from familiar ground so that you are able to understand what I am talking about. If you know what a fraction is, let's begin from there. So a fraction is any number that can be written in the form a all over b. All right, that is what a fraction is. Okay, any number that can be written in the form a all over b, where a and b are integers, where a and b are integers, where a and b are integers. So this basically is what a fraction is. And so when we talk of fraction, we talk of numbers like, let's say, a half, we talk of numbers like a third. All right, there are numbers that are terminating, there are numbers that we can almost tell how they'll end. Okay, all right, so those are what fractions are. They're basically numbers that we can express in terms of a over b, and a and b usually belong to integers. That's okay, good. Now, I want to also say this, that whenever you can write a number in the form a all over b, all right, that is, whenever you can write a number in the form of a all over b, that is as a fraction, we say that that number is rational. Okay, so we say that that number qualifies to be called rational number. It's a rational number. It's a number that you can write as a fraction. It may also include a whole number. Remember, this may include a number like 1. All right, this may include a number like 2, because we can write 1 and 2 is also as in the form a all over b. All right, so basically 2 here, for example, would be the same as 2 all over 1. So this here is still a rational number. We've written 2 as a fraction, that is a over b, and of course 2 here is an integer, a is also an integer, hence that qualifies to be a rational number. All right, so that's it. So basically, I want you to know at this particular moment that any number that can be written as a fraction qualifies to be called a rational number. Hence, a rational number is any number that can be written in the form a over b. So basically, all fractions are rational numbers. Yeah, all fractions are rational numbers. All right, so let's put that aside. And I want us to look at the complete opposite of the term rational numbers. So the complete opposite of the term rational numbers is what we call irrational numbers. All right, is what we call irrational numbers. Remember, rational numbers are numbers that can be expressed as fractions. They're numbers that terminate. They're numbers that even if they were written as decimals, you need notice that they have a recurring trend. They can always be written accurately as fractions. All right, these numbers may include even 0.5. Okay, 0.5 is a number that can be written in terms of a over b. A number like 0. Let me not go that. 0.5 basically. Let me leave it at 0.5. Sorry, 0.5 can be written as a rational number, or a number like 0.3 recurring. 0.3, that is what I was looking for. 0.3 recurring. Remember, I have a dot right above 3 there to show that it's recurring. So this here is also a rational number. Okay, why? Because we are seeing a trend where 3 repeats itself to infinity, it repeats itself to infinity, and therefore we can always write it as a fraction. And if we write it as a fraction, we know it will be a third. So this basically, that is what a rational number is. And so the complete opposite of that is what we call irrational numbers. And so irrational numbers, however, are numbers that cannot be written as fractions. And they, even if they were to be expressed as decimals, they would not be terminating at any point and showing any recurring trends. All right, so they, first of all, one thing I'm saying is cannot be written For a number to qualify to be irrational, we're saying cannot be written as a fraction, cannot be written in the form a all over b, of course, where we are saying that a and b are integers. So basically, whenever you cannot write a number as a fraction, a complete fraction with accuracy, that's the first qualification. That is the first sign maybe that it could be irrational. And also, if you're dealing with decimals, we are saying that it is irrational if it is not terminating. If a decimal is not terminating, if it's not terminating. For example, 0.5 is a terminating decimal, all right? 0.5 here is a terminating decimal. But if you have a number that is going to infinity, is continuously extending and giving new numbers without terminating, we say that that number possibly could be irrational. And of course, we also say that these are characteristics of irrational numbers, okay? We also say that in case maybe they are decimals, they are not recurring, okay? Not recurring at all. Not recurring, okay? Remember I said 0.3 is a recurring decimal, all right? I say that 0.3 is a recurring decimal. That is to mean that 3 there recurs to infinity, okay? 3 there recurs to infinity. And of course, that is a third. We can express it. We can always express it as a fraction, and it should be a third. However, if you have a decimal that is not recurring at all, it is giving new numbers and going on and on and on and on, and basically we cannot tell when it will end, and we cannot even tell whether it's showing any form of recurring numbers. We say that number is irrational. An example of irrational number, for example, is pi. Pi is an irrational number. Now, if you have a calculator, you can go to your calculator and try to find the value of pi and tell me what you're getting. So basically, the value of pi, if we are to estimate it, because the one we know is actually an estimation, the value of pi would be 3.1428571143 and on. It's going on. It's not terminating at any point. It keeps moving, keeps going on. All right, so one thing I want you to note about this number, like for example pi, is that it is not terminating. It is not ending anytime soon. It is a number that is going to keep giving us new figures to infinity. Another thing I want you to notice is that it is not showing any recurring numbers. Okay, it is 1, 4, after the decimal point, it is 1, 4, 2, 8, 5, 7, 1, 4, 3, and it keeps going on and on and on and on. All right, so that therefore means that pi is what? Is an irrational number. All right, so another example that I would give as an irrational number would be okay, so this is my first example. I'll name it A. For B, I want to speak of the square root of 2. All right, I want to speak of the square root of 2. Okay, if you look at the square root of 2, what do you get? When you look at the square root of 2 as a decimal number, of course, as a decimal number, you notice that it will give you 1.4142135 6, 2, and on. Basically, it is not terminating. That's the first thing. It keeps giving new numbers, and we can keep finding other numbers to infinity. We can do it for 10 days, 3 days, a year, 3 years, 4 years, a century, and we will keep getting numbers coming from this particular number. That is the root of 2, and therefore it is not terminating. That is the first thing. Another thing, when you look at the numbers after the decimal point, they are not recurring in any way. There is no trend of a number repeating itself. It is 0.414213. Basically, there's no trend here. Okay, we cannot say that this number keeps repeating itself. All right, so it's recurring, and so we can write it as a fraction. No, it's not recurring in any way. All right, so basically that means that root 2 here is an irrational number. And that is what we want to talk about today, because surds are usually irrational numbers. So now that you know what an irrational number is, I want to go ahead and define a surd in the simplest mathematical definition I know how. Awesome. So let's define a surd. So basically, I want to give it the layman's definition. And I want to say that a surd is any number. All right, any number. This is any number whose root, okay, any number whose root is irrational. That is what a surd is. A surd is any number whose root is irrational. All right, a surd is any number whose root is irrational. Let me tell you what this means. So basically, we know what a root is. Okay, so a root is this sign here. That is what a root is. So any number whose root is irrational, we say is a surd. For example, we talked of 2. And we said that when you find the square root of 2, you'll find an irrational number. All right. So we try finding the square root of 2, we won't be able to find what it is. All right. Another example of a surd is the root of 3. Okay. Another example of a surd is the root of 3. All right. So when you find the root of 3, you find that it is also non-terminating and non-recurring. Okay. Basically, it is non-terminating, non-recurring. Basically, it is irrational. It is an irrational number. So anytime you have a number whose root is irrational, we say that that number is a surd. Okay. Anytime you have a number whose root is irrational, we say that that number is a surd. Now, I want to also say this, that the reason why we are saying, okay, I want to differentiate. I want to give key points. Yeah. So for it to be a rational, it must have a root. Okay. For it to be a rational number, it must have a root. Must have a root. Okay. For it to be a rational, it must have a root. That is one. Then another thing, for it to be a rational, for it to be not a rational, for it to be a surd, for it to be a surd, it must have a root. For it to be a surd, it must have a root. And for it to be a surd again, it must be irrational. The root must be irrational. So those are the key points, all right, that qualifies a number to be described as a surd. That it must have a root, and the root must be irrational. That therefore means that not all irrational numbers are surds. So you won't just pick any rational number anyhow and say that it's a surd. For example, pi is not a surd. 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 Yes, pi is irrational. I agree. Pi is irrational, but pi cannot be expressed as a root of something. Okay, we cannot express pi as a root of a rational number. We cannot express pi as root of it, and therefore we say that pi therefore is not a surd. Okay, pi therefore is not a surd. So any number whose root is irrational is what we call a surd. For example, we can talk of root 2, we can talk of root 3, we can't talk of root 4. Why? Because the root of 4 is 2. The root of 4 is 2, and 2 there is a terminating number. All right, it is a number that can be is a rational number. 2 is a rational number. It's a number that can be written as a fraction. All right, it's a number that can be written as a fraction. So basically, for you to understand what a surd is, you have to have better and proper understanding of what rational and irrational numbers are. But the most important thing is that you should be able to spot them. So most rational numbers always have the root sign, and of course, when you find the roots of those numbers, you find that they are irrational. So that's what that is what a surd is. So for the next point, I want to maybe point out on classifications or orders of surds. Okay, let me just talk of order of surds. Order of surds. Order of surds. So surds can be of different orders. For example, when you have a surd, okay, surds are usually in the form n root n, the n root, usually in the nth root, okay, in the form n root. So whenever you have a form, whenever you have a surd of order 2, of course, which we know as square root, okay, we say that this here is an order 2 surd. All right. So whenever you have a surd where the n value here is 3, then we say that this is a surd of order 3. And whenever you have a surd where the n value is 4, we say that this is a surd of order 4. So those are the different orders of surds, and I want you to get accustomed and used to that. Okay, so basically you cannot these are two different surds. Okay, let me just leave it at that. These are two different surds. A surd of order 2 is different from a surd of order 3 and a surd of order 4. So that is one thing I also think you should be able to know. So in this class, the takeaways should be the definition of what a surd is and what you should expect when we're talking of surd. That a surd must have a root, and the root of that surd must be an irrational number. Okay, for example, we can talk of root 2. Okay, we can talk of root 3. Okay, so whenever you can find the root of a number, then we say it's not, a surd. For example, the root of 4 is 2. 2 is a rational number. Okay, we can write 2 as a fraction. That is why we are calling it a rational number. Okay, so 2, therefore, for the root 4 there is not a surd. Root 5 is a surd. Okay, we can also include it here. Root 5 is a surd. All right, root 6 is a surd. Root 6 is a surd. All right, and we are going to see more of why we are calling these numbers surds. We're going to see more of that. Then it will also help you understand what we are talking about. Root 7 is a surd. Okay, root 7 is a surd. Okay, why? Because it's, first of all, it has the root sign, and the square root of 7 is actually an irrational number. You can use your calculator to find that out. All right. Mostly, I want you to note that most of these numbers are prime numbers. I also want you to note that. All right. So most of these numbers are prime numbers. It's something I also need you to note. When you speak of root 8, okay, root 8 is also a surd. Root 8 is also a surd. All right, root 8 is also a surd, and there's a reason why root 8 is a surd. So also, anytime you can write a number as a prime number, as a factor of a prime number, always know that that number basically is going to be a surd number. Anytime you can write a number as a factor of a prime number, also know that that number is basically going to be a surd, because you see, we can write 8 as 4 times 2. Okay, 4 times 2. And so when you look at we'll look at that in our next class. I don't want to go ahead of my stuff right now. All right, so 8 is a surd. When you speak of root 9 is not a surd, because we can find the square root of 9, and that is 3. Okay, we can find the square root of 9, and that is 3. When you speak of root 10 is a surd. Okay, when you speak of root 10 is a surd, right? Because first of all, it has a root sign, and another thing that we're also saying is that other than having the root sign, it is irrational. When you find the root of 10, it will be irrational. Okay, it's very easy to tell if it's going to be irrational or not. Just look at the number, and if you can rewrite it using a prime number, if you can rewrite it with one of the factors being a prime number, then basically it's going to be a surd. All right, so that's it for this particular class. We've looked at what a surd is and given a few examples of what a surd is, and we've pointed out what a surd ain't. Okay, so as much as surds are irrational, not all irrational numbers are surds. Example, pi is not a surd. Why? Because we cannot write pi as in a root form. We cannot write pi in a root form. Okay, as much as it's irrational, yes, pi is irrational, but we can't write it in a root form, so therefore pi is not a surd. all right, and many other constants in mathematics. All right, and many other constants in mathematics. So that's it for this class. See you in the next one. If you have a question, drop it in the comment section and I'll get back to you as soon as I can. Thank you and have a lovely day.